Hi there, folks. Today we're going to be talking about Module 2, Set Theory. We're just going to be doing a brief introduction. And so, set theory is the study of sets of objects, their unions and intersections, and all of the abstractness that can arise. These are structures which we deal with all the time in the real world. Whenever we classify an object, we are saying that it belongs to a certain set, but not to others. And these classifications help us better communicate ideas. That's really the biggest, broadest picture of what set theory is all about. It's trying to understand how we can classify things. And once we've started to classify things, we can try and better understand the sets and their connections. And so, first things first, what is a set? A set is a collection of well-defined objects. And the question always arises, how do we define well-defined? Because that's kind of an important thing. Here are some examples. And so the prime numbers form a set, as do the letters of the alphabet, as do people with the last name of Smith. All of those are well defined. If we think of something like the greatest bands of all time, that would not be well defined because we aren't sure which bands we are going to be including on the greatest bands of all time. Would Paramore be included? Maybe. And so that's where we need to try and come up with some better, clearer definition. We would need a list of the bands which are included in the greatest bands of all time. There are many notations for representing sets. Most of them are going to be using the curly brackets. There is set builder notation is one of the more popular ones, and I'm sure you'll learn the fundamentals of that. But once we have the idea of sets, uh, we can ask questions like how many elements are there in the set? Are two sets equivalent? Is a set a subset of another set? And so is a set included within another set? Can we combine sets to make new sets? And what is the union or intersection of sets? And so when we have multiple sets, how can we start combining them together? One nice visual to do this is the Venn diagram. Also, Euler diagrams do the same thing. Venn diagrams are a way to visualize the interaction of two or more sets. This is an example which is humorous from the website XKCD. And so things on the front page of a university website, things people go to look for on the site. And you can see that the only thing that is in the intersection of those two is the full name of the school. And so the idea is simple. Each circle represents a particular population, and characteristics or elements are represented in the circle. Uh, or elements are, yeah, if there is a shared element, that is represented in the intersection of the circles. If there's something which is in neither of them, sometimes you'll see that on the outside of the circles. It's a great visual for representing the relationships between sets. And it gives us a way to understand the structure of the sets and how they are interacting with one another. This is an example with two circles. Sometimes you will see them with many, many more. And as you're dealing with more and more complex situations, you're going to see more and more complex diagrams used to keep track of all the data. Another thing you'll be learning about in sets is infinite sets. You might not have a lot of experience with infinity. We're not going to get a lot of experience here either because infinity is really a calculus idea. It's the idea that something can go on forever. Some sets have an infinite number of elements. And so one example would be numbers. Numbers have an infinite number of elements. If we were dealing with the set of letters, that probably would not have an infinite number of elements. But numbers certainly does. Uh, there's actually multiple types of infinity also, higher orders of infinity. For instance, if we think about the natural numbers or the integers, that is actually one of the smaller infinities out there because the real numbers has a larger infinity. The way we can start to compare these is by using one-to-one mappings between these sets. And we'll learn the basics of one-to-one, but we won't go too far into the idea. Really, we just need to understand that there are some sets which have an infinite number of values within them. And that's our brief introduction to Module 2 set theory. I'll let you get to it. Good luck, folks.